Hello, madam.
Hello, madam. Hello, madam.
Vaishnavi ma'am, you are very late.
Hello. 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 Hello, Sarika ma'am, are you there? You are not audible, ma'am. No, you are not audible.
Let me just try once.
Yeah, you are audible, ma'am.
I can? Can you hear me now?
Yes, yes. Shall we start?
That's good. Yes, sure. Let me just open the YouTube link for the comments and everything. So we good to go?
Yes. Okay, very good evening to all. This is day 4 of our webinar series on Idea to Deployment AI Project Bootcamp. I, Professor Rita Kadam, once again welcomes you all. Over the last 3 days, we had wonderful sessions filled with knowledge, practical lessons, ideas, and real-life experiences from our expert guest. Today, we continue this journey with our another special guest. It is my pleasure to introduce Ms. Sarika Tyagi, who has over 11 years of experience in financial services and IT, with deep expertise in Power BI, SQL Server, data warehousing, ETL and business intelligence solutions. She has worked with leading investment banks, consulting firms, delivering end-to-end BI solutions, building dashboards, optimizing databases, and helping organizations turn raw data into meaningful insights. She is also highly skilled in tools like SSIS, SSRS, SSAS, Tableau, and Lightweight, and had led projects that improved decision making and efficiency for global clients. With her strong technical knowledge and rich industry experience, Ms. Tyagi will share valuable insights with us today on how analytics and data-driven solutions can help in real-world problem solving. Before this, I would like to invite Dr. Sagar Pandey sir, head of the Department of School of Engineering and Technology, whose tireless efforts and academic stewardship have greatly contributed to building a strong foundation for our students and faculty. May I request you, sir, to share your thought with us?
Yeah, ma'am. Just a so yeah, very good evening to all. Uh, I would like to welcome the participants for this wonderful webinar series on artificial intelligence. I would like to welcome ma'am on the behalf of Department of Artificial Intelligence, Data Science and Machine Learning. Welcome ma'am. I hope this particular session will be very helpful for our students. Today's topic is again very interesting because we'll be explaining regarding the foundation of the data, how to build the data set and how to work on it. So definitely it will be helpful for our students. I would request all the students to make the session more engaging and interactive. Please do ask your queries and concern in the chat once starting with the Q&A session. Over to you, ma'am. Thank you for your valuable time.
Thank you, Pandey sir, and thank you, Rita ma'am, for such a nice introduction. Good evening, students. Good evening. So I understand that you have been going through these AI project. Sorry, Sanjay sir, Sagar sir, are you saying something?
No, ma'am. Please carry on. Please carry on, ma'am.
Just put my screen over here. Okay. So I understand that you have been using the AI. Let me share my screen so I can share the slides already. give me a second. Sorry, bear with me. I'm not able to share my slides. Sorry guys, sorry about the issue. Can you guys see my screen now?
Yeah, ma'am, it's
Ma'am?
visible. Please proceed further.
Yes, ma'am, it's visible.
Okay. Yeah, just wanted to say that I understand you guys are listening to all the speakers about AI projects. And before I start, I just wanted to know how, if you can quickly type in the chat box just to test if you can listen to me, you can respond. So if you can just type in the chat box that what is the first word that comes into your mind when you hear about AI or artificial intelligence? Because I know you have been hearing about it a lot. So it would be, I'd like to know, what do you think? Let the comments come in. Okay, audio is clear. Thank you. Can you type in the one word that comes into your mind as soon as you hear AI now? Let's see what we think as a group. Learning. Machines having their own mind. Okay. That's good. So that's what we do, really. Automation, that's another good one. Yes, of course. Advanced. It is working like a human. Yes. That's smart. Yes. So that's what you think about, right? Or every time you hear AI, you think about like all the flashy, shiny things, all the whatever that you can just give it some instructions, then you can just everything will come through. You can just ask anything to chat GPT or any AI and it will do it for you. That's all good. That is AI. But have you ever think about like how it all comes together? How is it actually managing to do that? How it's so smart that it can reply to any of your questions. It can suggest you things. It can suggest you the restaurants where you can eat and everything like that. So how many of us know or think about it? Like, how is it all actually getting together? So that's actually what is the part of AI project is the data. And it's not always all this shiny and flashy. There are some things first that needs to be done, which is the data, and none of you actually just thought about it. That it actually to the future, to do the automation, to do the deep learning, machine learning, anything you can think of, it's all coming through the data. Hello, my name is Sarika Tyagi, And I'm here today to give you some insight to the other side of the AI project, which is the data, how data works, how it all comes together, how generative AI or agentic AI, because you guys are all engineers, so you might be thinking of generative AI, agentic AI, machine learning, deep learning, and even prompt engineering. But it all comes together only if you have the correct data. And that's what we are going to deep dive in today. Let me go and see if I can just... So somehow my screen is not coming in the show mode, but that's all right. I think we can just go to the next one. This is... Okay. Can you now still see my screen? I'm not sure why it's not going into the next slide. Does anyone else has control to my slides over here?
No, ma'am, you can click on that.
Yes, so I'm trying to click on it. That's what I have no control. I can't click on anything.
Can you try with pressing F5, ma'am? Yeah, ma'am. Currently, you are muted.
Can you
Yes,
see my
ma'am.
screen like
It's
changing the
updating now.
slides?
Yes, ma'am. Yes, you can continue.
Oh, okay.
Yeah.
All right. Okay, so this is the agenda. So the plan, what we are going to discuss in the next hour. It's first we will set up. We'll start to with setting up the context of how data works and why it is so crucial and how it helps the AI projects and BI projects. Then we can go into the data journey, then how the data exactly travels from source systems to ETL to warehouse and to then to the AI projects and BI projects. And we will do some deep diving in ETL and the data warehouse because that's the building blocks of the data that we work on. And then we'll show some real world usage, how then if it all come together and you can see it working in BI and AI projects. Yep, let's start. So like we were talking initially, sorry we got interrupted so much. Like we were talking initially, the glamorous AI, because whenever you think about AI, you think about the chatbots, the flashy screens, the automated things that can work with you, work for you, anything that you want. But that is not always actually working in the background, in the behind the scenes. What is happening is that the data is working for you. We have all the AI models have lots and lots of data that is actually working hard for you to get the results that you want. So it might look like that all the left side of the screen, if you're seeing this, the left side of the screen, you might think that, oh, this is the magic. This is where magic happens. But actually, when you dive into the data, we always forget. Everyone kind of keep missing the reality, the fact here that actually the magic is done by the data, the right side of the screen. That when you see the data, that's how the magic happens. So it's like, for example, you can think it as like the superstar. For example, if you are working with a superstar, he's a star. All the fame is given to the star, but actually, what is happening behind the scenes is he has a team. Like he has a team for the makeup artist or PR or anything that comes to in your mind. They are making him successful. They are actually working for him to give him every tool and everything that he needs to actually find out, to actually do his thing, so he can be the superstar. He gets all the fame. The team never knows. But one thing that you can always take away, that these superstars keep changing. Yeah, they keep changing. They come and go. But the behind the scene teams that can hold on to some other. As soon as a new superstar comes, you can actually do the same thing for him and provide him all your services. You will still be there, but superstars come and go. So why I'm saying this, I'm here, I'm in this data field, it's for about 14-15 years now, and I'm working on the data from the very beginning, and I have worked for the desktop applications. I have worked for the websites, and then the BI came into picture, and now the AI comes. And everything there, it has been changing a lot. We are progressing, and we think like we are so much progressing with everything, and this is a new thing. Even if you think about the tools, even for BI, first it was business objects, then ClickView, then Power BI, Tableau, so many. But the data behind the scenes stays the same. I'm working on the data since the beginning, and it never fades out. It never goes out of fashion. It's always there. Everything that comes into the market needs the data and the data structure and a clean data warehouse from which it can interact to get the data to actually serve its purpose, to build up on it. So that's why it will here to stay. There might be changes. Tomorrow there might be something else comes in, but the data will still be there. It will still be needed, and it will still be useful. It will keep making the superstars. All right, quiz time. So, tell me, in a real world AI project, now I know that you know about. I'm talking about that we also use the data and all the data artifacts. In a real world AI project, what takes the most time? Give me in the comment box A, B, C, or D, where A is building and coding the AI models, B is cleaning, preparing, and managing the data, C is deploying the model to users, and D is presenting the results with dashboards. Can you tell me what do you think, which one takes the most time in an overall AI end-to-end project? B, that's correct. Exactly. So this is what I'm talking about. The overall AI project or BI project, whatever you do, that's nice to know that you guys think the data preparation takes more time than actually the whole project, and that is true. Now, can you guess how much percentage this data project can take into an overall AI project? Now that you guys are so confident about B, so can I ask you, what do you think, how much percentage of the time it takes of an overall AI project? It's 40%, 50%, 20%, whatever you think. So actually, the overall project, if it's 100 days project, 80 days are spent in preparing, cleaning, and preparing the data for the AI model or the BI model. Thank you, Arush. It's 50%, but not 100%, of course. But yes, 80% of the time, it's all the investments, the time goes into the data preparation and data cleaning and managing the data. Once it's all there with the structured data warehouse, you have all the retrieval capability, and then it doesn't take a long time to build any other system over it. All right, so let's see the data journey. So what does the data foundation looks like? Like, it is a journey. Data is in the source systems. We gather all the source systems, put it together, then clean it, put it in the data warehouse, and then we actually provide it for BI or AI projects. So we have to clean it. Once there are lots and lots of systems where source systems in the real world, there are so many systems. I'm going to cover it in a minute. There are so many systems that you have to get the data from, and then you have to extract it from all these systems, load it, transform it, and then load into data warehouse, and then you share it with the Power BI or any AI project that you are working with, and they will be able to build over it. So this is the ecosystem. So I work for a bank, guys. I'm a data warehouse lead in a bank, where I get to interact with all kind of teams. So we have all the business teams, and then in the technology world as well, we have a BI team. We have a data warehouse team that is, of course, us, and it's a new team that is coming through is now the AI initiative, which is taking all the AI initiative. So every team does their own job, their own work. They do not really need anyone else. And so BI projects, they are making their own projects, their decision-making systems, and they are providing the flashy reports to the management. And now the AI initiative came, and they also are doing their own thing. They do not interact much with the BI. But guess what? What is common in all of that is they all have to interact with us. Either it is business or it is technical teams. everyone has to interact with us in order to get some useful data, because there are so many systems, they are working on their own, but they cannot actually make one single statement without getting all the data that we have. So, for example, this one, in the bank, if we see the ecosystem works, we have the internal systems. Internal systems like the trading system, which is, for example, we use the Gloss and Prism. The Gloss system is for security, all the security bookings. The Prism system is for all the derivative bookings, and so on. We have ELF for all the ledger booking. So they do their work. Then we have this core banking systems, like that handles deposits, withdrawals, fund transfers. Then we have a lending a system which handles all the credits, lending, mortgage. So all these internal systems that we work with, we need to extract the data from them. They are all different systems managing the data in a different way, different format. Then there are apps, like the bank provides apps, their internal app to their customers, like the mobile app you must be using. For example, HSBC, I have HSBC Bank, so I use HSBC app, and then we have some data there. Then there are some marketing apps, that we run ad on Facebooks or ads on some other applications, other websites, and then we get all that marketing data to make the decisions. And same way, digital ad, and we also have a separate marketing app. I don't know if it is something in other banks, but we also have that. And then there are other sources as well. This is only that bank owns. Then there are other sources. For example, the regulatory data that comes from government. All the policies, everything that we have to apply to book the trades or to finalize the reporting, we need that regulatory data. Then we have this market data feed that we need, how it is going on in the market, whatever, like the prices for all the instruments and everything, we do get it from the market feed. We have, for example, we have the FX rates. Every day, every second, it changes. Those rates coming in from Bloomberg. So all this makes a huge data set and totally separate things. If they're working on credit and lending, they don't care how the deposit and withdrawal and fund transfers are managed or working. But what happens is, for the business decision or to make the AI do a lot of things for you, we need all this connected together so that we can work on the decisions. We can make the decisions based on the data, the information that we have. And that is the most challenging part of the data management that you have in the real world. If you are learning now, you're engineering students, you must have done some ETL at some point, just getting the data from an Excel and putting it into the database, working in the tables and SQL queries. But in the real world, this is the most time-consuming, most critical part of the data warehouse system that we do. All this system then is loaded first extracted from all these systems, because all these sources have different format, different kind of data, and they mean different for same thing. They can mean differently in different systems. So that also we need to consider when we are actually taking them in and putting them together. We transform and load, do the ETL. We will cover that in some time. And then it goes to data warehouse, where it is structured and stored. And then it goes to the business intelligence projects, or same way data science projects, which is basically the AI projects. And based on that, we do the decision making. Or like we always have either the one idea to perform to all this cycle, because someone got some idea to do for the bank, or we have some problem for in the management that they want to solve. So there are two things only that for that we actually start working on anything. Right. Quiz time. Tell me true or false. The primary purpose of business intelligence tools like Power BI is to make visually appealing reports. Yes or no? Or true or false, whatever you can do. Let's see the response coming. So what we are asking here is if the primary purpose of business intelligence tool like Power BI is to make visually appealing reports, meaning visually all the dashboards and all the flashy reports that we do, that do we use the BI only for that? Okay, I'm getting some mixed answers here. False, yes. Well, in real world, not exactly. Actually, what happens is, though it's a best feature of the BI projects that it provide a flashy. Exactly, Arush. Well done. Its primary purpose actually is to analyze the data because see, you can create a proper flashy dashboard and show everything that see I have done this graph and I'm showing how much we are making this year and how much we were making last year, or and I can also show you the graphs up and down when we are going low, when we are going up. But the thing is, however flashy you make it, whatever graphs and charts you introduce, if the data is wrong, then the decision cannot be made. If it is not a logical data which provides some information, then the decision can't be made. So these systems actually, the main purpose of any BI project is to make the decisions on the information that is correctly provided to them. So if you say we can do a lot of charts, if you just provide them a table and put your charts are not working, your flashy reports are not working, but the table is working, and you say, okay, this much sale this year, this much risk is on this project, and you just provide them all these many trades now, and you provide all the numbers correctly, they'll still work. The management might not be very happy to see that, okay, it's not really very good looking report, but they'll still manage. But if there's some problem with a warehouse, with the data that we are providing, that can cost bank a lot of money. It is always all the data is always tied back to money, not the flashy things, not the visuals. The data is always tied back to money. If you are not able to provide them the data, correct data, when they need it, what they need, then it's always a failed project. Whatever you do in the AI or whatever you do in BI projects, it's always a failed project if you cannot provide the correct data to them. And that's why our job becomes so critical. So let's dive into how we actually do that, all that we just talked about, the data management. This is the foundation of the data, how we build a rock solid foundation that we talked about. So there are so many stages that you can divide it into, because we have to really make sure that everything is correct. So for example, we have talked about data sourcing. We need to identify, it's not only that we have some data coming in from some sources, but they might not be the correct sources that you should be getting the data from, especially because it's a bank where I work. It's very important to get the correct data in, not just from any system. So to identify the exact data that you need, the source system, and not to miss out on any source system, on any relevant source system, that is very important. So you need to do the sourcing correct. Then there is data ingestion. So when how you are actually extracting that data from the source systems, it doesn't only have to be fast or correct. It's also need to be scalable, because they might have the data might keep increasing day by day. So you really it should be scalable, or they introduce something else that they're providing today in the source system. It's not there tomorrow. It comes in. It should be your data ingestion process should be scalable, and to handle all the diverse sources that you can get, and to push it into the centralized system. Then there's data profiling. What data profiling is basically to find out, to identify any issue in the early stage. Like this data might cause issues, that this might be dirty data or some missing values. So any inconsistent data, you have to, during the data profiling, what we do is we try to identify any issue before this goes into the system or before it goes into the BI, so we can stop making any error in the final measures or final data. And then we do the cleansing. We try to cleanse the data, all the data quality issues we struggle. It's different than data profiling. It's like there is a star in some number field or something like that. We just try to make it accurate. We have predefined rules, what we can and what we can't do, because again, this is again the problem with it, because it's a critical part. We also need to think about auditing, and we need to see, we cannot just replace anything that we feel like, okay, this is the name is a number, let's not use it. It's not like that. You have to agree on the rules of what we can change, can't change. And sometimes it's like we do know that it's wrong data, and we have to go back to the source system to ask them to correct it, because we can't correct it at our own. We can't change our roster. We can't a company name from say ABC star to ABC, because everywhere else it's ABC. We know it won't match to our system, to other data, other tables, or in the BI system. So it will give you some weird results, but then we have to go back to our system, because when the auditing comes in, you have to find out the data lineage. We'll talk about it in a minute. And to like where the data is coming from, who is the owner of it. So that all that we need to consider when we are actually making the cleansing rules. And then comes data modeling. Data modeling is basically the data warehouse, how you model your data, how you store your data. It's all the main consideration is that it should be correct first, and then it should be really easily retrieved. We should be able to retrieve it very easily, very fast, so we can use that data in the other systems. So that's where the part comes in. All of these structures, the small structure in the data foundation, they're all important, because every stage we do some cleaning, some work on the data to make it better and better for the downstream projects or the BI and AI projects that we are talking about. And then comes data governance. Data governance is like all the policies, the processes that are like organization wide, or from government, if we have some policies or something that we need to work on the data, for example, that who can see, but the finance team cannot see equity data, or the equity team should not see finance reports. So all those kind of policies we need to put in while we are actually creating the data, all the governance, all the AD groups we create, we grant permission on the data, and we do the row level data security as well, based on for the data governance point of view, and to see that our system is not accessible from someone who is not authorized to access our system. So even though we all work for the same bank, because we are IT, we are data warehouse, we have the authority to for all the data. We can see all the data. But when we are distributing this data, we need to consider who we are distributing, and this is auditable. Every year or sometimes every quarter, we have these audits going on to find out like if we are missing on any rule or something, and there are penalties, and there are internal audits and then external audits. So this is again very missed whenever we talk about data cycle. We always miss this thing, but this is again very important. And then data monitoring, it's again the alerting system that you put in place. There has to be an alerting system when you are loading the data. If there is something which is not correct, which is if there is some failure in the ETL process, the pipelines that you created, or there are performance issues, for example, you are some long running queries are taking a long time. So because again, we have the time constraint, as well as we have just seen all the sources that we get data from. It's a lot of data to consume, but just consider this. For example, the price data, it's changing. All we have is night to just consume all that. And in the morning, it has to be ready for the users. It has to be ready for the traders to see what happened yesterday, or to make the decision and to book the trades the next day. So it's a very short time and a lot of things to do. So we should have a monitoring system in place which emails you, which alerts a concerned person to if there is something running for a long time. One report started to run 3 or 4 hours, and then we do not have any time to do the rest of the things in the business hours when they have to do. And again, because these are the critical points, these are the critical data points based on which our decision system is built on. So if they are delayed, the business is delayed, and most of the time there are some deadlines for regulatory reporting that we do. So this is again gets very critical. We always have someone on night support and so on to just do these, to check these, or if some alert is sent, we look into this. And then comes the data lineage. This is again like we should be able to say in the endpoint when we have this particular trade, we should be able to say from where it is coming, who booked it, how, from all the systems that it came in, and if there was any change from the actual trader who booked it or until we have it in our BI system. So we should have that data lineage maintained. And that's what I was saying about when I was explaining data cleansing, that we can't just change anything that is not working. We have to go back, and it's a long, lengthy process, and there are a lot of things that we need to consider in that. So yes, data lineage is required for the traceability and auditability. Then comes data security. Data security is different. It means to protect your system. It's not like data governance. It's not like protecting it from the just to check the ownership and authority. It's actually protecting the sensitive information and be compliant and giving the access controls and encryption, that your system is not hacked or your system is not used for the stolen information, and all that checks that we need to, all the technical checks we need to put in this layer when we do the data security. And we have to implement we have to show to authorities that we are taking all the measures that are required to secure our data. We do have these trainings on like quarterly basis, half yearly basis, how to secure your data, and how you cannot, how to not, I mean, of course, how to protect your system than outside world. That is very important, especially when you are working for a bank and it's like a lot of investment data for a lot of firms. We are answerable to them. So again, this takes a lot of time and a lot of considerations and a lot of planning how we can do this. And the last but not the least, it's continuous improvement. Whatever goes in and all these stages, we can always improve. We can always keep evolving based on what is changing around us. If there are new policies coming in, so we do again everything for that policy, or there is no new source system came in that we need data from, then we include that. And any technical advancement, for example, if it's saying that there are a lot of like we are saying, the tools keep changing, and if that is more robust, that gives you more robust system, we try to change technology as and when is feasible. This is basically the most of the part of any project that we work on. Once this is all done, then only we can move on to something else, something bigger. This is the foundation. Let's quickly cover some of the basic concepts like data warehouse. As I'm telling you, it's a collection, it's a central repository for all the system, all the data of the organization, or from wherever you need the data for the decision making, or for your AI projects, for the idea to become a deployment, to get into the deployment state. Whatever data you need for that is stored in the data warehousing. It can be from different stores, various sources, and then we structure it in a way that it's very easily accessible, and it's not taking as long. It's fast and it's reliable. And then of course we provide the data warehouse is the thing that you connect your BI to, and you check, okay, you get all this data and then visualize, make insights, make reports, and all that shiny thing. I'll go through a little concepts of the building blocks of data warehousing. So these are they are the data warehouse. We don't just dump in anything. We don't just dump in all the data. This is the heart of everything that we are talking about. We can't just dump in. We structure it intelligently, smartly, because this is something that we need to use. Before that, the data exists in different source systems, and they can't really use it properly because they have either very less data, just 1 day's, 2 days data, maximum a month's data they contain, or it's not usable because it's lacking all the other aspects of that data, right? Because they are just considering one part of the whole system. But data warehouse is where we have answers to each and every business question. We should have, if it's a good data warehouse, we should have all the answers, whatever a management can have, whatever the business can have. We should be able to answer that, looking at all the different data categories that we have. And for that, the dimension model gives us a lot of flexibility, a lot of reliability. For dimension model, what we have is basically fact tables and dimension tables. What we do is, fact is like what happened, what exactly happened, to record that, right? Sales, your sale happened, a business transaction, a bank transaction happened. So that is a fact which is stored in a fact table. And then this fact is actually connected to different dimensions, the surrounding tables, which is those actually give you answer for who, when, and where. For example, a bank transaction happens. Okay, which branch, right? So you'll have a dimension for branch. which customer, then you'll have a dimension for customer, and then all the details about the customer. So this is dimension model. This works perfectly for organizing the data. And then we have some design patterns also that we apply to data warehouse, which is like star schema, snowflake schema. There's one galaxy schema as well. Most of the time, majorly in every data warehouse, we use either star and snowflake, mostly snowflake, but star schema is the base of everything. What it says, what design patterns are, it's like the system. I mean, this is like, it tells you how to arrange this dimension model. So we have the dimension model for data warehousing. We have fact tables and dimension table, but these schemas, these design patterns tells us like how to arrange these. Like one fact is connected to all the dimension, and how. So for example, in star schema, we have one fact and multiple dimensions connected. In Snowflake, those dimensions are also connected to different dimensions. So that's how it, based on your need, based on your requirement, and what kind of volume, and a lot of things to consider before you decide on which design pattern you want to use. But this is the broad answer to like how to use this. Okay. And yes, true or false. So if you're still awake, let's see, take one round of question. Tell me, the roles of a data engineer and a data scientist are mostly interchangeable. True or false? What do you think? Yes, that's correct. It's false. It is mostly, we take it as a same thing to be done. Like, okay, data engineers work with data, data scientists work with data, but it's not the same thing. It's one builds the data, one builds a system, builds the foundation, and the other one actually build upon the information provided by the previous one, which is data engineers. So data engineers mostly work in the background. Thing that I talked about, all the ETS and all the warehousing is happening, data engineer comes in, and as you start to work on the AI projects, doing the machine learning and deep learning and all those smart things, then the data scientists come into the picture. But they have to, whatever you do, wherever you go, whatever you decide, you might want to go for AI project, or you want to do something else, or you want to go in the business someday. So, but main thing, one thing never changes, that whatever we talked about, if you have some understanding of the data, if you have some understanding what you have, then you will be able to build good systems. You will be able to build a useful, productive system. So this knowledge, this data, the data information, this knowledge of how you deal with data, and what all the source systems you have in your system, and how you are managing that data, and how can you efficiently use that data, is very important in any role that you go. Somewhere it is, if you are a data engineer, you'll be more into it, you'll be doing more deeper analysis, deeper work in this area. But if you are in anywhere else, in any other area of the project, you will still be needing, if you are like before this, if you are just sending the data, or if you are receiving the data downstreams or upstreams of any data warehouse, they should also be aware of this data technologies, the data terminologies, and how it's being used. So all that, when we do everything that we have discussed, after we work on everything, then you provide your data, your foundation, to the other projects like BI projects and AI projects, and then they use, and then they get the fame, right? Then they start showtime, right? And then they make this, which is the dashboards, which is based on all the trade data, the risk data, the total, so all from all the parties, whatever we have, the price data. Based on that, we are creating this. Same way the trading inside, and this is the analytics. So we get all the data from different sources that we talked about, and we talked about, and that's why it's coming here. Now, can you guess this one, the first one? If how much time will it take if you have a Power BI app which is connected to a well-structured data warehouse? What do you think? How much time this will take you to build? This takes usually to build. So usually it's not really that long. I can create it if everything is there. If the data part is sorted and data warehouse is a good efficient data warehouse I'm connected to, then in Power BI, I'll just take 5 to 10 minutes to get all this stuff together, and voila, you have the proper reports, the flashy report to send to the management, and they can start deciding on it. So yes, the same with this, it's again a complicated insight, which is actually telling you a lot of information, but this is all again coming from the data warehouse, exactly that, the same model we are using. That's what this is about. And I think I'm done for this topic. If you guys have any questions, can you just put it in the chat box and I'll try to answer. All right, guys, put your questions in the chat box and I can start. I can answer them if you have any. And otherwise, just remember the garbage in, garbage out, whatever you learned today, you can't take in any garbage. Otherwise, whatever project you're working on, if you're AI developer or BI developer or the data warehouse developer, you will not be succeeding in your project. It won't be a success project. So always remember that the quality of the input matters. What quality of data you are taking and how you're managing it, it matters. And that's all from me. I can leave.
Students, you can ask the questions.
Data foundation life cycle in short. Yeah, actually we went through the data foundation life cycle, isn't it? But in short way, it's like really you receive the data from different sources and put them, use ETL to put them into the data warehouse, cleanse it, profile it, and use it for the downstream systems like the Power BI projects or AI projects that you might need. So machine learning is, again, it's like it is kind of it's towards the data science. Of course, it's towards when you generate AI, things, then we use. I do not use machine learning for now, but it's like using Python, and you get the data from warehouse, and then it's not you can't get the whole of the data using the machine learning. You just need the data, what you are needed for AI to perform, and use it. It's more likely to adding the features than the data. Yes, that's correct. Using AI agents, we do store the data fast, and we can access. It's not a lot of data though. It's again for AI projects as well. You need to have a big centralized repository where you can actually put the data, keep the data. For example, for us, we keep like 7 years, 8 years worth of data into our systems. That won't be possible like that. You can type in any, I think the chat is always available. So you can type in any question that you have, and maybe after the session also, I'll try to answer them in the chat if you like. And thank you all for having me, and thank you for joining the session.
Thank you so much.
It was good experience.
Thank you so much, Sarika ma'am.
My first time taking the session for students, but yeah, it's like it was worth it.
Thank you so much, ma'am, for sharing your knowledge, practical experiences with us today. Your talk has given our students, faculty, a better understanding on how data and analytics are applied in the real world. And your presentation on the data journey, data foundation life cycle, and the key concepts of the data warehouses has truly expanded our understanding of how data forms the backbone of the modern organizations. And I also take this chance to thank our Vice Chancellor, Dr. Pimpri, sir, Dean, Dr. Vijay Patil, sir, our HOD, Dr. Sagar Pandey, sir, and Dr. Swati Shirke, ma'am, for their constant support in making this series possible. A big thanks to all our participants for your presence and enthusiasm. With that, we conclude day 4 of the AI Project Bootcamp. We look forward to meeting you all again in the next session. Thank you so much, ma'am.
Thank you. Thank you.